consider a liquid drop. Okay. Now, due to the property of surface tension, this liquid drop will tend to acquire minimum surface area. That means the force of surface tension will act in such a way that it will make all the molecules come inside, like to acquire minimum surface area, right? But the volume cannot shrink to zero because it will counter the law of conservation of mass, because that cannot be go to zero. That means if volume is not going to zero, it means there must be some pressure inside this liquid drop which is countering the internal force acting on this liquid drop, right? So this internal pressure is doing what? It is countering the force by applying a force on vertically outward direction. That is the only possibility so that the liquid drop can be in equilibrium. It means that the outside pressure is less than the inward pressure, and that is what this topic means, excess pressure inside the liquid drop. So this excess pressure inside the liquid drop is inside pressure minus outside pressure of a liquid drop. Okay, so I'll draw this diagram again because we have to deal with the inside pressure only. This is the liquid drop model and this is inside pressure. This pressure, due to this pressure, a counter force is acting which is balancing the force of surface tension, right? Now this is this excess pressure is P, which is P inside minus P outside. Now let's say due to this pressure or due to the increase this excess pressure, there is an increase in radius of the liquid drop. Let's say the liquid drop's radius, which is r right now, it gets increased to r plus delta r, where delta r is very small. So the new liquid drop is like this, radius increased by very small amount. So what is the work done by this pressure on the liquid drop? What is work done? Work done is force into what? Displacement. What is force? Force is pressure which is doing this force into area, or which area? Force, where is this formula coming from? P is equal to F upon A. So F is pressure into area. So what is area? The area of this sphere right now is whatever the increased area is into displacement. This P, minded that this is the excess pressure. So this becomes P into the area is 4 pi. What is area right now? 4 pi r plus delta r square into displacement delta r, right? Is that so? Is this equation right? See, if I have to consider the work done is done by force into displacement, where in force, if I am taking pressure into area, that area would be the original area, not increased area, because increased thing is already already adjusted in this displacement thing. So this thing is actually, this equation is actually pressure into 4 pi r square into displacement delta. This is the value of work done which will provide the potential energy stored on the liquid drop, right? Now let's find increase in surface area. Increase in area. Why we are finding increase in area? Because we have just found the relation of surface energy. What was surface energy? It was surface tension into delta A, or increase in area, and this surface area was stored as potential energy, or surface energy is potential energy in the film. So here increase in area is, what is final area? Pi r plus, what is the formula? 4 pi r square, right? So it becomes 4 pi r plus delta r square minus 4 pi r square. This is the initial area. If I'll take 4 pi common out, I'll be left with r plus delta r square minus r square. Okay, this becomes 4 pi r square plus delta square plus 2r delta r minus r square. This term gets cancels out. Now delta r was very small change and delta r square would be too small, so hence this term is neglected. This is neglected. Therefore we are left with this thing and that thing. So 4 pi into 2r delta r becomes 8 pi r and delta r. This is the increase in area. Therefore, the potential energy stored due to that work done will be, what is potential energy? Surface tension into area. So 8 pi r delta r times surface tension. This work done by the liquid drop is responsible for the storing of potential energy in the liquid drop. That means these two are equal. Compare them. P, which is the excess pressure, into 4 pi r square into delta r is equal to this term, which is 8 pi r delta r times S. So here the things which are cancelling out right now are delta r, pi, 1 r and 2. So here I am left with 2s and 1 r only. So the formula for excess pressure inside a liquid column is 2s upon r, where s is the surface tension and r is the radius of liquid drop.